And we are on a little bit of shortened schedule. We got 10:07. All right. We're doing okay. I think we did we just do 1 and 2 of that yesterday? Or did we do it to 3? 1 and 2 maybe? Yeah. Okay. We'll start with number 3. And we'll do number 4. Alright, then we'll move on. So just kind of review a little bit of the last few days. We're going to start with question 3. That's where we ended up at from the last thing. So it's find the exact and the approximate coordinates for a point rotated 280 degrees. So I like to draw a picture a lot. So 280 degrees. Which quadrant would that be in? If this is 1, 2, 3, 4. It's in the fourth one, right? 270 straight down. We'll be a little bit past. So here's 0 always on the right. And we're going to maybe draw it like that. I don't know. There's 280. Okay? Find the exact and approximate coordinates. So our coordinates, x and y. How do we find the y, the vertical part? Which function have we been using to find the height here? Sine, right. So we can do sine of 280. That would be the y coordinate. And we just talked about cosine being the horizontal one. Okay. Would that be considered the exact or the approximate coordinates right there? Exact, right, Daniel. We didn't type it in, we haven't rounded anything. Those could be the exact coordinates. The approximate ones, we're just going to type them in the calculator, right? We are going to need our calculator a lot for today, so especially people at home, if you don't have it right there with you, go ahead and go get it. If I type them in, let's go ahead and just round it to maybe 2 decimal places, 100th place. Right. Jack, you want to get us the cosine of 280? 0.17. 0.17. Okay. And sine? Joe? And your sine of 280?
Why not put in degrees?
Yes, I want to make sure you're in degrees. Okay, let's see. We're going to check. Sine of 280. Yep.
Negative 9, 8,
okay.
5.
Oh, okay, that's fine. Now let's think, does this make sense? Let's make sure we're in the right mode. Besides just checking your calculator to see if you are. Cosine is the horizontal distance. If I draw a little tiny triangle, like here, does it make sense? Our cosine is kind of small, 0.17. That's the horizontal part here. Yeah, that's pretty tiny. And then, why is this negative? The sine. Down, it's like underground here, and then it's very, very long. The longest, farthest down it could be, straight down would be -1. So it's pretty close to being almost all the way that same length. It's not quite cut. So, good. We did good. Right. Let's take a look at number 4. Find the value of cosine if sine is -1/6. Use the Pythagorean identity. And so we're reviewing a little bit from yesterday before we move on. So sine is -1/6. That's one of the sides in our triangle. That's the vertical part in our triangle. Right? If I draw this, there's only a few places that we could have our angle be here, since sine is -1/6. Right? Caitlin, do you think of which quadrants we could have that in, since our sine is negative? What? 3 and 4. Yeah, it's going to be this bottom half. So if I am drawing a picture, I do want to make sure I'm drawing it kind of somewhat accurately. So our sine is the vertical part, the height of our triangle, -1/6. And I need to find the cosine, which is really that horizontal, the base, even though this is kind of drawn weird. And then we know our hypotenuse is 1 in this unit circle. So we're going to just fill our things in. We have our one side squared plus other side squared equals the hypotenuse squared. Okay. Now before we reach for the calculator, let's do this without the calculator this time. Let's square -1, be +1, and 6 squared is 36. kind of jumped a step there. But I'm going to make that 1 into a fraction with that same denominator, but it still means 1. Okay. Then if I subtract 1/36 from this 36, 35. What? Are you okay? Okay. And then I'll square root both sides. Square root of 35, I don't know what that is, and I can't really simplify that, but I can simplify square root of 36 to be regular 6. Well, let's think about that. So we're looking, this is cosine. Cosine represents the horizontal part, right? If horizontal is positive, that's over on the left side. If it's over here, if it's negative, it could be over here on the right. Which Caitlin said it could be in the 3rd or the 4th quadrant. We didn't really know. I just drew one picture. So it could be either of them. We don't have enough information to know which side it's in. So cosine of my angle is positive or negative square root of 35 over 6. That's what we were working towards. Part 5, question 5 here says, how would your answer be different in number 4 if the angle must be in the 3rd quadrant? So it's exactly what you were looking into. Let's see somebody online. Can't see everybody's names here. How about Chase? How would our answer to number 4 be different if it says, okay, we're only in the 3rd quadrant? No? Okay, so cosine is horizontal. Right? If we're in the 3rd quadrant, that means we're on the left of our circle. That means we're over here. Okay? It's still going to be the same numbers. It's still going to be the square root of 35 and over 6. But instead of it being both the positive and the negative, right, to show that we're on the left of the circle, which one is going to be the only possible answer here? The negative one. If we're on the left, that represents we're going negative over here. So it'll be negative radical 35 over 6 is only versus the positive and negative option. Okay. What if we said, hey, this problem was actually in the 4th quadrant. This angle was in the 4th quadrant. Now our cosine would be positive. It's over on the right half of the circle. So it would just be the positive answer. So we just kind of have to read our questions carefully and make sure we know. We don't skip over any details if there's extra details provided. Okay? Alright, let's take a look at what we're going to do today. We're just going to continue with our cosine stuff a little bit. I do need you to have a calculator with you. If you don't have a calculator, we should kind of have one by now. That's our multiple years in school. But we do want to make sure that it's, first of all, in degrees. Right? And what we're going to do is find the values for the horizontal distances on the graph using your calculator. Okay? This is a little bit smaller than I intended for it to be on your paper, but all these angles are going by 15s. Okay? We're going to try to find the horizontal distance. So I'm going to draw, let's start with 0 degrees. Okay? Can't really draw a triangle there because it's not going up at all, it's just flat, right? So I just have my kind of line there. The question is, how long is that line? From the center, if it goes all the way over to 0, that's what we're looking for. What's the horizontal distance here?
1.
Okay? And it's 1, right? That unit, if we're talking about the unit circle, the radius was 1. This is all the way as far as we can go to the right from our center. Okay? Now if you type in cosine of 0, we should get 1. So check, make sure you're in the right mode and stuff. Cosine of 0, you get a 1. Okay. Let's take a look at the next angle. We're just going to write these values all around our circle. So if we look at 15 degrees, right, our 15 degrees is in here. That's the little inner angle, 15. Yes? Sure. We know the hypotenuse here is a 1. We want to know this length. Now I kind of maybe should erase this little nub on the end there. Right? It's a little bit shorter than all the way to the end. Right? If I want to find this base here, I can do cosine because it's the adjacent side and the hypotenuse is 1. So we're going to do cosine of 15 equals x over 1, or just cosine of 15 equals x. So what is that if we use our calculator? Cosine of 15. Noah, you want to try that new calculator out?
No.
Cosine of 15? You can do this first. There's somebody out already. There's somebody out already. You can do this first.
Okay.
Cosine of 15.
Cosine 15. Radical 6 plus radical 2 over 4.
What?
Hit the second button and then hit equal.
The second button.
You see, it says second shift.
Shift. 0.9659258.263.
Alright, we'll round it to maybe 0.97. That was weird. I don't know why that did that. But if you think about this, our horizontal distance, it's almost all the way to the edge, but it's a little bit too short. It's not quite 1, so it's a little bit under that for our base of the triangle here. Okay? Yeah?
How is it not 1?
So do you see how my triangle, if I draw straight down from this angle, there's a little bit of a gap between there and the actual edge of the circle? Okay? So the radius from here to all the way to the edge is 1, but it's just a little bit under that. Okay? So 0.97 is pretty close to 1, but we're not going to just round it up.
Like if you use parameters or whatever.
Yeah.
You would get 1.
Well, you don't know. You only know one of the sides. You only know that hypotenuse side, right?
Yeah.
So you can't actually do the Pythagorean theorem unless you know one of the other two sides.
So you're not lying to us?
What?
No.
No, but we
But
do
you just
the
told
other
us
side.
that you just told us that that side was 1.
Yeah, all the way to
No,
the edge.
no.
This guy,
Hypotenuse.
You
hypotenuse.
told us the hypotenuse. You also told us
Yeah.
this one. The one over here. Not
This
the,
one's not
the
one.
vertical.
No, I'm sorry. That's. I mean, I should erase my little weight. That was at the. That we did the 0 degree one. I wrote it down. I'm moving on. Okay.
It's 0.97.
Sorry about that.
That makes sense.
No,
Yeah.
the horizontal is 0.97.
Yes. The blue horizontal is 0.97. And I'm just recording that next to each of my angles.
What's
Maybe
the
that's
problem?
what? It's not a parabola, no.
No, like what's the problem?
I don't know.
We just do a sine 15 or whatever.
We're doing cosine of each of the angles. Yep.
Yeah.
That's all we're doing. Right? So maybe I'm making it more confusing with the picture. I'm gonna try to do one more. I'm just recording my cosine values around my circle just so you can record it somewhere. Because we need it for another thing. So let's look at 30 degrees. So from 0, here's 30. I'm gonna draw straight down. Try to. Okay. The only values we know. Well, let me erase this here. Okay. We only know the hypotenuse is 1, right there. These other two things we're recording from previous experiences. Okay, we know that one's 1. We want to find this base right there. So we can do cosine of 30 degrees would equal our base divided by 1, which is base base. So what's cosine of 30 degrees? Give me our calculator. You know?
0.87.
0.87? Okay. So we're just going to record those. I'm just having you record the cosine values for each angle, just all the way around, because we're going to end up plotting those points. So I want you to write them down somewhere so you have them. Now you want to kind of put that away? Okay. So all the way around the circle, you're going to keep going. You're going to cosine of 45, cosine of 60, cosine of 75. You don't have to draw a picture each time. I would just try to hopefully help us understand what we got. They are going by 15. So all the way around. Okay. After we do a few of them, this is, we round it to 2 decimal places maybe. These are the first few-ish. Okay. So we all should have a calculator. We should all be typing in cosine of 45, cosine of 60, cosine of 75. Writing it down. Keep going all the way around the circle.
Wouldn't it be 0?
It would be. Yes. Because your sidewaysness is nothing. Okay. Keep going all the way around. Once we get to 90, as Joe pointed out, that's going to be 0 because we're not moving sideways at all. Right? But once I move to the 105, it's going to be very similar to the 75 answer, but it's going to be negative to represent we're on the left of the circle. Okay? Should be getting very similar numbers. We're not going to randomly get a different decimal come up.
I thought it was going by 15.
Yep.
It said 105.
Yep, that's 105 right there. This is 90.
Oh, sorry.
Yep, that's okay. When we get over to 180, all the way over to there, it's the same distance, it's the same all the way as far as you can be from the center as we were over at 0, but now we're on the left, so we're going to show that it's a different side by saying it's negative, but it's still the same distance away from the center. Then when we get down here to the third quadrant, they're also going to be negative, right? Lance, I don't know why you're not writing things down. Do you have a pencil?
Yeah.
Okay, write them down. Going all the way around. This really is not hard right now. You guys are just typing stuff into the calculator. Okay, going all the way around the circle. Cosine of all those angles. When I get straight down to 270, like Joe pointed out before, I'm not moving sideways at all. You're directly, think about on that Ferris wheel, you're directly over the center. So that's going to be, the cosine would be 0 there. And then when we switch over to this other quadrant, they're going to start getting positive again to represent that we're on the right side of the circle. So generally those are around our numbers. Okay. If I were to generally quickly plot some of these points, at 0 degrees, we were at 1. 15 degrees, we're just a tad under it. This is just a little under. You know about that. And 90, we're at 0. Then, after we got to 90 degrees, then they start becoming negative. Right? So now these points are going to go down here. They're going to be negative until I get to 180. That's all the way at -1. This graph is not the best. But then it's going to start coming up here. And it's going to come up to here. Okay? This is going to be the graph of cosine. I would like you to still try the homework tonight. You did not get to as much as I would have liked. But still try it.